Let's do solver. This is setting up solver for the assembly problem. We had an earlier video about doing a graphical solution for the assembly plant making two types of vehicles, a compact car and a compact SUV. Our objective is to find the number of compact cars and SUVs to make every day to maximize our objective function, subject to constraints on the body shop, paint shop, and assembly. So in setting this up, you first put down your objective function. I like to do that at the top, and then you have the number per day, how much you're making per day, and we have X, and let me say X is just the ECZs, right, the number of ECZs, and then the Y is going to be the numbers of BFCs, okay? And I'm just going to start this out by putting some kind of just dummy numbers in there. Let's say 1 and 2. Now below it, I'm going to put my objective function, which is the operating margins. And it's $1,000 or just one operating margins, and these are in thousands of dollars. Okay. If you're doing this for real, not just for your own amusement, it's good to put units in so you remember what units you're talking about, right? Because someone might come and think that's $1, and then 1.3 for every BFC we make. Okay, then to get the total, which is also in thousands here, we're going to say is equal to sum product. I'm going to highlight my decision variables, and I'm using my magic finger to hit F4, and that will put, if you're a PC and you use your magic finger and hit your function 4 key, it'll put dollar signs around it. You could type in the dollar signs if you want to. Those will be very important to us when we do the constraints. And then I do a comma, and then I highlight. I guess I'm being spied on. Highlight the coefficients. So I get 3.6. So what is the sum product? The sum product is if you take the number of ECZs, X, times 1 plus Y times 1.3. That's the same as the sum product function. It's just a lot simpler to say sum product. If you don't like sum product, you can just go ahead and type this in. Okay. But the reason we're using sum product and those dollar signs, right? The dollar signs means absolute addressing. It means you always go up to these decision variables. Whereas if you don't use dollar signs, it means you're using relative addressing. And I think you know that from your Excel class. Okay, so then you put your constraints in. And you have the same thing. Let me just copy and paste that down. And then it's just a matter of saying your body shop, your paint shop, and your final assembly. Every X consumes 4 hours in the body shop, 10 hours in the paint shop, 8 hours in the final assembly. And every SUV or Y consumes 7 hours in the body shop, 10 hours in the paint shop, and 6 hours in final assembly. So what's the total if I'm making one car, one compact car, and one compact SUV a day? I just copy and paste that down. Okay, and just to verify, okay, 10 times 1 plus 10 times 2 gives me 30. And just to verify, because I use the dollar signs, I'm always picking up these decision variables. And where I don't use the dollar signs, it means just go down here. This is your relative addressing. Okay. And this is how much I have on hand to use. I have 3,200 hours, 3,200 hours in the body shop, 5,000 hours in the paint shop, and 3,800 hours in the final assembly. And this is not useful. This is not needed, but it's very useful. Reading a few textbooks, everybody does it this way, and I like doing it too. It's just a little clue to say we're looking for less than or equal to constraints. Let me move that away. Okay, so for you to catch up, let me just go ahead and do some highlighting here so I won't get as confused. Let's highlight, that's money, so let's make it green. Let's do a light green. These are my decision variables, and so I'm going to make that a light blue. This is my boundary, so boundaries are warning, so I'm going to say, hey, I'm going to make that yellow. And then these are my changing cells, and so I'm just going to make these gray, like that. So this is a live spreadsheet. I can do a little bit more to make it a little bit fancier, putting on, you know, things like that. Okay, and so as I change the 1 and 2 up at the top, my decision variables, everything else changes. My total operating margin changes. The total amount of time I'm using the body shop, paint shop, and assembly are changing. Okay. So now I want to set up solver, and it should be under data. Data. It's an add-in. It's made by Frontline System. It's an add-in. If you don't see it there, it's because you did not load it. And so to load it in PC, you go File, Options, come down here to Add-ins. And then down here you have Excel add-ins. Right, see that down at the bottom, you say go, and then you want to click solver add-ins. Okay, and then you hit OK. I'm going to cancel out. So let's go ahead and do solver. So what we have up here is data solver, and here's the dialog box. Let me just clear that out. My set objective is my objective function. I just click that. I want to maximize profits or operating revenue. You'd want to minimize something like cost, time, distance, things like that. So I want to maximize it by the changing cells. These are my decision variables. If I was making solver, I'd say decision variables. Constraints, you think you start to type in the constraints, and no, you don't. You hit add. And then what you do, they all go in the same direction, so I can do them all at once. These are the cells that change because they have the sum product in them. They're called cell references. And then the constraints over here, I can just highlight them. And they're all less than or equal to. I have a drop-down box, less than or equal to, equal, greater than or equal. Integer like means 1, 2, 3, 4, 5. Binary means zeros and ones, but I want the less than or equal to. And I say add, no. If you say add, it says add more constraints. You're not going to do that. I'm finished, so I say OK. Okay, and then I come down to make constraints none. That's right. I want to make positive, non-zero cars and SUVs, and I want to change this to linear, simplex linear programming. And then I hope I'm all done. I hope I didn't make any mistakes. One last look. 1 and 1.3. 4, 7, 10, 10, 8, 6, 3200, 5000, 38. It's real easy to make a mistake with all this. And then I just say solve. Boing, boing. All right. Good news. We found a solution. Everything is satisfied. And I'm going to hit answer and sensitivity. We'll be looking at that in class. And then we say, okay. All right. So what do we have? We're making 100 cars and 400 SUVs for a total operating margin of $620,000 a day. Okay, you make a lot of money in the auto industry if you're selling product. And then we have these constraints. The body shop is binding. I'm using up all my body shop time, and I'm using up all my paint shop time. So those are binding. And then the assembly is not binding. And if you know anything about the slack, this is the slack is 0. I'll type in slack here for you. I'm using up all my resources here. What I have, can do a little formula in fact. What I have minus amount I actually used is 0, so that's my slack. And if I copy and paste it down, you see that my assembly is not binding, so I have 600 hours left over in my assembly, and so I have a slack of 600. Okay, and that's how you do solver for linear programming problems for the assembly. And you know, you have to be really careful entering the data. If you have any typos, you will get the wrong answer. You have to be really careful in setting up that dialog box. When you hit solve and it goes okay solve and it gives you an error message, I've done that so many times. Okay, but if you're very exacting with it, it's a lot of fun to do, and you end up with the solution. I hope that was helpful and you got something out of it, and I'll see you in other videos. Okay, bye-bye now.